Alright, so I hope this is recording. We are looking at skill packet 5, which is logarithms and or exponential functions and logarithmic functions. In this skill 5e, we've looked at properties of logarithms. You have to know these properties, these formulas, and be able to use them well in doing these problems. Here the idea is a substitution, using these properties and then substitution. They do not want me to use the change of base formula on a scientific calculator. I'm going to use my calculator to do just simple addition, subtraction, and multiplication, but I'm not going to use the scientific, the logarithmic part on this because that's not the intent. Um, so here they give me that log base a of 6 is approximately equal to this 1.955. Log base a of 2 is approximately equal to this number. Log base a of 5 is approximate to that, to 3 decimals. So it wants me to use these approximations to approximate log base a of 12. But it also expects me to know the properties of logarithms. So when I look here at 12, I think, well, how can I rewrite the number 12 in such a way that it uses either the 6, the 2, the 5, and I can see that 12 is the same thing as 6 times 2. And I have a property of logarithms that says if you have the log of a product, that you can write that as the sum of logs. So I have a property that says I can split this up into the log base a of 6, and because this is multiplication, I can rewrite it as addition plus the log base a of 2, and now it has told me that this log base a of 6 is approximately 1.955, and that this guy, the log base a of 2, is approximately 0.756. So we can add these together. Now here, I don't necessarily need a calculator to add these, but my mental arithmetic skills are not the best, and especially in this video, I don't want to embarrass myself and add these together wrong for you, so I'm going to hopefully key them in the calculator correctly. Alright, 2.7. So, I really didn't need the calculator to add these together. I'm just doing it, I guess, out of either laziness or lack of confidence, however you want to describe it. So there's your answer for number 16. I hope you agree. Let's move on because the directions are the same. So again, I want to somehow rewrite this using the information that I have given, the log of 6, the log of 2, log of 5. I can look at 25 and see that it's 5 times 5. Really, I guess what I can do, which is even better, is to recognize 25 as a perfect square, and it's 5 squared. 5 squared is the same thing as 25. Well, by the power rule, I can take this exponent of 2, and I can move it out in front of this coefficient. And I have log 2 times log base a of 5. They have told me that this log base a of 5 is 1.756. And again, I don't necessarily need the calculator, but to not make a silly mistake for you and to not embarrass myself, hey, I get 3.512 as log base a of 25. Because see, without this given information, I don't know what the base is. All I know about this base is it's positive and not equal to 1, Alright, so log base a of 3, and I look here, well, I don't have that, so what am I going to do? Oh, well, 6 divided by 2 is 3. So it jumped out at me quickly that when I had multiplication, that 5 times 5 is 25, and that 6 times 2 is 12. For some reason, it just didn't, it's getting late. It just didn't jump out to me that 6 divided by 2 is 3. So I can rewrite the number 3 as 6 divided by 2, and I have a quotient rule that says if you have a log of a fraction, it's the difference of two logs. That I can rewrite this as log base a of the numerator minus log base a of the denominator, and it's given me both log base a of 6 and log base a of 2. So by substitution, I can find this log base a of 3 that they wanted. If I copy the numbers right, and if I punch them in the calculator right. Alright, so I'm getting 1.199 if I've copied that. Sometimes I even switch numbers when I copy it from the calculator, so I hope I haven't done that. So there's my final answer for problem 18. I apologize, I kind of coughed into the microphone there. I couldn't hit that pause button fast enough. Alright, so in this next problem, here it's a little bit more obvious. I know I can get this fraction 2 over 5 by taking 2 divided by 5. I can see that I can write this single logarithm as the log of the numerator minus the log of the denominator. And they've told me that log base a of 2, and I apologize that my a's and my 2's probably look alike to you, but I can read them. Log base a of 2, this first value is 0.756, and this next value, if I try to emphasize that that's a, is 1.756. Well, even I don't need a calculator to see that that's a negative 1. Alright, so I hope that helps. Let's move on to the next one. 150. How are we going to break down 150? Well, let's come over here and look at 150 as 15 times 10. Let's look at this as 3 times 5 and 5 times 2. Alright, so we have the 5's and the 2's, and the 3 we can get by 6 divided by 2. So what's the easiest way to... Oh, well, I've got a 6 right there. I've got 3 times 2 right there. So I can rewrite this, boy, it is getting late, as 6 times 25. 6 quarters is $1.50. So yeah, I've got that multiplication right. Now, I can write this now as the sum of two logs, log base a of 6 plus log base a of 25. But remember, I can write 25 as 5 squared. So this log base a of 6, they've already told me to substitute to replace that with 1.955. And by my power rule, this exponent, I can pull it out in front as a coefficient. So I can write this as 2 times the log base a of 5. But they've told me that log base a of 5 is 1.756. So all I have to do is take that and multiply it by 2, and I'll have this second term. So again, a calculator is not crucial here like it was with using the change of base formula. This is a $1 calculator at Walmart or Dollar General that you can get at the checkout line can do this for us. But I could do it, but I'm afraid that I would make a silly mistake, and I don't want to embarrass myself. So if I've keyed that incorrectly, I am getting 5.467. Alright, so let's see. So again, here we have multiplication, and we can rewrite this as the sum of two logs. I can break this apart and say that I have log base a of 5 plus log base a of a. Now, they tell me that log base a of 5 is 1.756, but They don't tell me what log base A of A is. What they expect me to recognize what it is. And it's not hard if you look at it right. Remember that this logarithm is an exponent. So here's this base of A, and A has to be raised to some exponent to equal A. Well, that's the number 1. Anytime that you have this base and this being the same value, A to the first power is A. Or if this was E to the E to the first power is E. 10 to the first power is 10. This is going to be the number 1. And I'm fortunate here that I don't need the calculator to add those together. Now, if multiplication was addition, remember the properties have division. If I have the log of a fraction, I can write that as the difference of two logs. So I have log base A of this numerator minus log base A of this denominator. And again, log base A of A is 1. And they tell me that log base A of 6, they say use 1.955 to 3 decimals. So I don't need a calculator to see that that's negative 0.955. All right, so what do we have here? Well, we have a product 6 times a to the 4th. So I can break up that product as the sum of logs. Now remember that 6 is being raised to the first power, and this a is being raised to the 4th power. Well, this first term, I know what it equals. They told me that it was 1.955 in the given. And by the power rule, this exponent of 4, I can pull it down in front of the logarithm as a coefficient. So I have 4 times the log base A of A, and I know that that's 1. So the second term is 4 times 1, which is just 4. And so when I add these together, that's what I get. All right, so I hope that helps. All right, now we have the log of this fraction, but that fraction is being raised to the 3rd power. I need to deal with that power first, and by the power rule, pull that down as a coefficient. And now, since I have the log of a fraction, I need to break this log up into a difference of two logs. Since I'm multiplying this by 3, I have to multiply both of these terms when I break it apart. When I have this log base A of 6 of the numerator minus log base A of the denominator, it's 3 times both of these terms, not just my favorite or not just one of the terms. It's 3 times, because this whole thing is equal to that difference. So I have 3 times the log of 6 minus 3 times the log base A of A, because I distribute that 3 through. Well, I know what log base A of 6 is. They told me. They told me that this log base A of 6 is 1.955. And they don't need to tell me that log base A of A is 1. I can figure that out on my own, and 3 times 1 is 3. So I can jump to a calculator and key this in. Three times 1.955 minus 3, 2.865. And remember, that's just an approximation of 3 decimals. Really, all of these equalities really should be approximations, but we're not going to go back and change that. All right, so what about, hey, that's it for this block. Hope that helps, and I'll talk to you later.